Alright guys, so the skills that we are learning today are huge. I mean, so important. You will use it for the rest of the year in all of pre-cal, basically for the rest of your math career, however far that goes, okay? And it's all about, in my opinion, knowing your times tables for sure, with speed for sure. So we memorized these. We used to have those sheets in 3rd grade where they would give us time, like 1 minute. How many of those could you do in 1 minute? And I'm not kidding, guys. For the rest of your math career, what we learned today with factoring can make it a lot easier or difficult, okay? So, factoring. First of all, with factoring, it's all about presentation. It's all about order of operations, okay? So this first one, anyone, you can yell out the answer. What is the answer to what I've written right here on this first line? 3? Are there any other answers out there? 5?
No,
4? Are there any other answers out there? So what is this symbol right here is my question to you. What is that? Multiplication, right? So let's do the bottom one. What do you think the bottom one is equal to? Just throw out numbers. Don't be shy. 1? What else? Any other answers? Okay, so order of operations is huge. So right now, with PEMDAS, the order of operations that I have are multiplication, which occurs right here, and then I have addition and subtraction, which occur right here. So the multiplication must happen first. So what I have is 1 times 2 is 2. I'll still add and subtract the rest, and you should have gotten 3. Okay? The second one is the same thing. Multiplication happens first, so 1 times 2 is 2. And I'm still doing this 2 minus that, plus 1. What do I get there? 1. So 1 was the answer there. With factoring, don't make it more difficult than what it is. All you're doing is grouping stuff. So now, it takes on a whole new meaning. What's the answer to this first line now? It's still 3. What's the answer to this one right now? It's now 3. So this was just coincidence, but my point is when you group them like that, parentheses is going to change the answers most likely completely because of order of operations. Okay? Alright, so what we're going to do is, back in Algebra 1, we threw in letters, and you saw things that look like this. And your teacher probably told you to FOIL this out. And FOIL meant just grouping stuff. The first, the outside, the inside, and the last. And sometimes what we said back in my day, what was first, outside, inside, last, may not be the same of what you see as first, outside, inside, last. Because a lot of people, when they see F or first, they think this whole thing is the first. Okay, but first is talking about the first term in each binomial. Guys, how many binomials do you see right now? 2. There's 2 binomials. And a binomial just means you have, bi is 2, you have 2 terms. Okay? So terms are separated with addition and subtraction signs. So if I had something like this, how many terms do you see? just one. You see one term because they're all glued together with what? Multiplication. You with me? So multiplication glues them all together as a mixture. Okay? Alright, so let's go over here and come back. O for outside is now the outside terms. A positive x and a positive 1. I is for inside, is a negative 2 and an x. And last but not least, the last number, L, would be a negative 2 and a positive 1. If you saw something like this, what would you do? What word comes to mind for you to do? Distribute, which is synonymous with what? Multiply, divide, add, or subtract? Multiply. So factoring is multiplication backwards. So it is kind of division for sure, breaking it up, but you're strategizing on how you place these numbers. Okay? Raise your hand if you learned something called the box method. Okay. So I will not use the box method, but what I'm using can still be used with the box method. Okay? What I'm going to develop with you is your number sense, to where if I said 64, you would be able to easily, quickly say, ooh, the factors of 64 are 1, 2, 4, 8, so on and so forth, and go all the way through to the very, very top. So what I'm building is this. 64 is 1, 64. 2, 32. You with me? You see what I'm doing? 4, what? 16. And if you didn't see it, look, you're just multiplying this by 2, and you're dividing this by 2. Okay? What's the next group besides 4 and 16 that will follow? Will 5 work? No. Will 6 work? No. 7? No. 8? 8. 8 will be with what? 8. So it almost looks like a rainbow per se. And how do you know when the middle number, when you're near the middle number, is basically taking the square root of that? That's how you know, okay, I've accounted for them all. Okay? So factoring. So if I were to multiply, because that's what this is doing, first is x times x. What's that equal? X squared. Outside is what? X. Inside is negative 2x. And the last, what's the last? Negative 2. Now, if I have 3 pencils and I add 2 pencils, how many pencils do I have? 5. But if I have 3 pencils and 2 erasers, what would I get when I added 3 pencils with 2 erasers? 3 pencils and 2 erasers. So when you see something that might look like 3, let's say x, and we have 2 erasers, can we combine those together? No. Just like we can't do it here, we cannot combine like terms there. Okay, so just ironing out some stuff here. So can I combine these two right here? Yes, because they're both of the family of x. Okay, x to the 1 power. So I'll have x squared, what? Minus x minus 2. What we just did is we distributed, multiplied. And all factoring is doing that backwards. Okay? But there's a lot of strategies on how to quickly do it in your head, how to quickly do it by writing it down. But nonetheless, our goal is to get back to this. You with me? Okay, so whenever I listed out all these numbers, all of these are what to 64? They're all factors of 64. I could multiply these things together, a couple or maybe more, and get 64. So these right here in purple, these are factors to this. You can multiply those to get here, and vice versa, you can divide to get back to your factors. I'm trying to conceptually make this so that you guys can learn it, I mean, really fast, okay? Because there's a lot of different methods that we're going to look at. Any questions? Okay. So, let's go ahead and go to our first example. We have x squared. This is in paper notes, guys. So, all right, so our first example is x squared plus 9x plus 20. Now remember, we are going to factor this by going back to what are the binomials or maybe monomials that this came from, okay? So real quick, before I begin, the very first method of factoring that you should always try first is GCF. Okay, GCF can simplify a lot of stuff for you. And then after that, you're going to go to the binomials factoring. There's many ways that you can factor, and I'm going to show you all of them. But the one that I ultimately want you to learn requires a lot of number sense. And this is the one that I want to start with immediately, okay? All right, here we go. I know that I will have two factors. How do I know that from looking at this equation? X squared. Because if it was x to the power of 5, guess how many of these parentheses pieces I could have? I could have 5. Doesn't mean I will, but I could at most. Okay, so the way I look at this, and it is kind of very similar to the box method, is I know that I have two binomials. And just that's why I showed you at the beginning. I know that I have two terms in each of these parentheses. And the first two will multiply to give me x squared. Okay? The second thing that I concentrate on are the last terms. Because these last terms will multiply to give me 20. So now, let's think about this. I could have 120. I could have what? 210. And then 45. And then that's it. That's like where the middle of the rainbow will reflect. And you'll start listing out the other numbers that you were on the other side. Guys, the square root of 20 is close to what? It's between what two numbers? 4 and 5. Because 4 is 16 if you square it, and 5 is 25 if you square it. So I know that this is somewhere between 4 and 5 is where my halfway point will exist. So where I know I got all the factors. Okay? That's step one of number sense. Okay, so when you're doing this, it's always best to try to go for the ones first as close to the middle as you can. If they don't work, keep going out. If they don't work, keep going out. Okay? So if the 4 and 5 don't work, then go to the 2 and 10. If that doesn't work, then go to the extremes. Okay? Alright, so let's try 4 and 5. And if I put 4 and 5 right here for scratch work, 4 and 5 has an opportunity to become two numbers. If I add, it can become 9. If I subtract, it can be a form of 1. You with me? And this right here is what we're trying to see is, do one of these numbers match that b term that I'm trying to get? This all revolves around the quadratic standard form that we've looked at so far when we were looking at standard ones. Negative b over 2a is this right here. And the goal is to get this b, where the a and c still satisfy. Do I have x squared? Yes. Do I have a form of 20? Yes. Could I add 4 and 5 and get 9? Yes. So I chose correctly. Now I just have to put the signs correct. You with me? Now look. This is a positive right here. That means these two signs must be what? the same. They don't have to be positive, but at least they're the same, because when you multiply, they will become a positive. So you tell me, either two positives or two negatives. Which one is it? Two positives, because how else will you get this positive when you add them together? Easy enough, right? Questions? It does develop. It gets a little bit more involved for sure. But these are called the factors. Okay, so these are, and let me write this off to the right. These are the factors. And if I asked you to tell me what are the x-intercept, otherwise the zeros, otherwise the solutions, otherwise the roots, otherwise the answers, all of these mean the same thing. What would the answers be? -4, -5. And you would write them like this. You could write them independently, or you could say the answers are -4 and -5. Either one will work. Why is it that way? There's the question. Because the answers in quadratics are where it crosses the x-axis. The answers are the x-intercepts. So what did I tell you? Immediately when you say x-intercepts, I want you thinking what equals 0? Why? So right here, this is all equal to 0. This is the y value, and all of this is like the function. Like all the f of x piece. Okay? Questions? So the answers for furthermore, the answers for a quadratic are the x-intercepts. We good? Alright, so now let's keep going. Because they do get involved, and there's different case scenarios and so on and so forth. We have x squared plus 14x minus 72. Very first thing I should always do, very first thing, is try to GC at. Is there something that they all have in common other than one that I could divide out? No, right? Okay. So we're going to factor this. Okay, so let's factor it first. I know I have two possible roots because of this thing right here, this power of 2. Okay. And what are the first things that I want to write out? X and x. Yep. You've just taken care of those first terms. Basically f for FOIL. So we just took care of f. Now let's look at what? 72. And yes, it is a negative, but I want you to think about those signs at the end. Let's think about factors first, okay? So, let's see. Some people are good at this. Some people will get better. What are the factors for 72? 1, 72, 236, 3, 24, 418. What else? 612. What else? Yeah, well, it's not going to let me move it this time. 8 and 9. There's a lot more. Okay? And the ones that we just did, that first one, they won't be that easy. They won't be that easy necessarily all the time. What are the two that I want you to start off with trialing and erroring? 8 and 9. So think of 8 and 9. 8 and 9 can either become what? 17 or what? 1. Is that what we have? No. So those didn't work. Okay? So let's keep going outward. The next ones that I want to look at are 6 and 12. 6 and 12 will either become what? 6 or 18. If I subtract, it'll be 6. And I know 6 minus 12 is a negative 6. And I know 12 minus 6 is a positive 6. All I care about is a 6 right now. What do we want? We want 14. Do we have that? No. So we got to keep trying. Okay? So 6 and 12 didn't necessarily work out. And you think that this seems like it's a lot, but it isn't. It actually, when you get good at it, it is the fastest way. Okay? Let's try 4 and 18. 4 and 18 will either become what? 22 or ding, 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 ding. Winner. Chicken dinner. There we go. 14 is what I'm looking for. So what am I going to write up here? Or 4 and 18, right? I know I'm going to use 4 and 18. And then the last step I just have to figure out is, what are the signs? You know what I mean? And I immediately look at this sign here. Because if this is positive, they're both the same. But if it's negative, then they're different. One's going to get the positive, one's going to get the negative, and they will still satisfy. When I do that, it will still equal 14 when I add them to get that B term. Ask me questions if you have them, okay? Who gets the positive, who gets the negative? Okay, so positive 18, negative 4. If you needed to distribute that and say a negative 4x and a positive 18x, and just like with the pencils and the erasers that I added together, we will get that 14x. You're good to go. These are your factors. These aren't your zeros. These aren't your answers yet. These are just your factors. When I set them equal to 0, what are my answers? 4 and negative 18. Now look, we didn't do it on the other one, but I'll do it right now. Skylar was asking, what does that answers mean? Well, we know it's whenever I cross the x-axis, and they will look like this. Here we go. At positive 4 is one of our answers. At negative 18 is our other answer. Now I have a choice. A parabola, which is what we're graphing, will either look like this, or it'll look like this. Which one of them, is it looking upward or downward? It's looking upward. And the reason why you know that is because it has a positive x squared. Okay? So this will look like this, and this is a rough sketch. But I don't want your sketches that rough. I want them even more precise. Okay? Let's find out. How could I know what the axis of symmetry could be? What can I do to find the axis of symmetry? Add together and divide by 2. Perfect. I could get the average. The average of these two things, 4 plus the negative 18 is? Negative 14 divided by 2? So negative 7 is this axis of symmetry. And if I wanted to know what that vertex was, I know it's negative 7, but it's something else, right? What do? Plug it into the original equation and get my answer. I could even plug it into right here. Look, I like to do it here too sometimes. Is take that negative 7 and plug it in right here. Guys, what's negative 7 minus 4? Negative 11. Here's that number sense. Where's negative 7 plus 18? 11. So a positive 11 times a negative 11, what do I get? Negative 121. All from what form? You just took the CFA over. All from what form? Factored form. So, okay, yeah, we took standard form to start. We used factored form to get all these answers and pieces and attributes to the graph, right? And then if we wanted to, we could even go all the way to vertex form with this thing, right? It would be, help me out, y equals what? With that vertex right here. X plus 7 quantity squared minus 121. Okay, and you just took, and I'm glad that we did wait until today to take this CFA because a lot of it connects right now. I have what form? Standard. I have what form? Factored. I have what form? vertex. From these three forms, if I wanted to know the y-intercept, which one's the one that I could get the y-intercept like that? Vertex, well, not vertex form, standard form. Because what am I going to plug into the standard form where x is at? 0. To get a y-intercept, I will plug in 0 right here. What happens to anything times 0? It's gone. So you see, what's left over is negative 72. Standard, y-intercept. Factored, x-intercepts. Vertex form, vertex. That's why it's called the vertex form. We good? Any questions from what we've done so far? Because if you understand the progress, the hard ones will not be difficult. I assure you.
Okay, I don't want to sound dumb, but where'd you get the 11 from?
This one right here? Okay, so remember how we got this negative 11? We were looking at this value here, at the x-axis of symmetry. So all I did was I put this negative 7 right here, and I put the same negative 7 right here. I could have, if I wanted to, put it here. But to me, I think it's easier when you're working with things x to the power of 1, mental math-wise, than doing the squared. The square, there's another form that you can use, but it's in pre-calc. If we have time, I'll still show you this year. Okay? It's called synthetic substitution. And it's easier than it sounds. It's just fancy. Questions? Alright, so let's move on to the more difficult ones then. And yes, it does progress. Let's go to 6n squared plus 9n. Okay, so 6n squared plus 9n. And I want to factor. To review, how do I start? Okay, he's saying you got 2 parentheses because of this. Joel, what are you thinking? GCF though first, okay? You're right, it will have 2, but you want to work with smaller numbers. So let's break this down first with GCF that has 1 parentheses. And guys, what's the GCF that you see between this? 3. Ooh, a little bit more than that. Not just 3, 3n. Okay, yes, 3n. So 6n squared and 9n. Our GCF is 3n. They both contain a 3n that I could divide out. Okay? This cancels to 1. What am I left with? 3. This will reduce to what? 2n. Because this n squared says I have 2 of those up top and only 1 on the bottom. So all these games that, you know, you have like small little battles between, let's say, variables. If I have 2 and I have 1, those will kill each other off, right? And then you just have 1 left over. So who wins? The top by 1. Okay? So we'll put 3n times 2n plus 3. Any questions? What's the next step? I realized I just said kill them off on that video. Anyway, so what am I going to do from here? That's it. There's no factoring. Remember what Terivia was saying? We could break this up into 2 if this was what? Squared? But I don't have any more squared, so there's nothing left to factor. You understand? Okay, so now, this right here is my factored form, but it's not my solution, because we need to set this equal to what? 0. Okay, here we go. Guys, anything, this is huge what I'm about to show you. Visually, look up here, please. Anything times 0 will equal 0. That means if this green piece equaled 0, it would make all of this equal what? 0. Okay? And the way we can account for that is just set that little green piece equal to 0 and solve for n. I divided both sides by 3. That canceled to 1. And what's 0 divided by 3? 0. What's 3 divided by 0? Undefined. You cannot divide by 0. Okay. So now that I found that first answer, again, anything times 0 will equal 0. So anything, like let's say this gray piece was equal to 0. And if I multiply it by more stuff, what's the whole thing going to equal? Still 0. So I have the other side, which is 2n plus 3 is equal to 0. You help me out. What's the next line that I will write? Negative 3, because you subtracted the 3 over. And then n is equal to what? Negative 3 halves. Stay away from decimals. Keep it as simple or an improper fraction. Questions? Okay. So what are these called, Tyson? What are these called again? Say again? Well, they're not both binomials. This is a monomial, and this is a binomial. But what is the word that I'm wanting him to say, guys? Factors. They're called factors. These are the factors. What are these called again? Anyone? The zeros or x-intercepts or answers or roots or solutions. Okay? Okay, so let's move on to the difficult ones. Here we go. Your first difficult one looks like the following. 4x squared plus 20x minus 56. Terugio, what's the first step? GCF. And what's the GCF, Terugio? Okay, so the other one was 3n because there was no what? There was no c term. But this one's a little bit different. This one has a c term. So you have to ask yourself, out of all three of these, what's the biggest thing that they have in common? Anyone? What do you see? 4. Okay? So 4 will divide, and Riley, what will be left? X squared plus 5x minus 14. Perfect. Cool. GCF is done. From here, Sarah, what would I do?
From there, you would find the factors of 14.
Okay. So, but we're going to practice. We're going to concentrate on this parentheses, right? Okay. So, we will have 2. The 4 is still out here. And Sarah, go for it. What am I wanting everyone to do at the same? What am I wanting you to do first from here? Yep, x's, because they will multiply to give me that. Okay? Nate, what's the next thing that I would want the class to concentrate on?
The negatives, because they're two different sides.
Which negative?
Where it says
Negative 14? Okay, so we're going to concentrate on this, right? And I want 2 things to what? Okay, so to multiply to 14. Just wait off on the negative for now, okay? We know that it's going to make, and as you get faster, yes, you can think of it to that level. Okay, so here we go. Factors, Morgan, of 14.
1 and 14, 2 and 7,
And that's it, right? So there are no other ones that will work. And let's go with Thomas. What are the 2 that I want you to concentrate on first?
So you start with 1 and 4, oh no, yeah, 1 and 14, right?
Not 1 and
No,
14.
2 and 7.
2 and 7, yeah. So from the center, we're going to work our way out. Okay, so let's start with the 2 and 7. So 2 and 7, Thomas, can become what 2 numbers? It could be 5 or 9. Is that what we want? Yes, that's what we want, because we see the 5 right here. Don't try to look for a 20. Don't try to go all the way back to the original because you GCF'd. Okay, so now you have a new B term that you're trying to get these things to add to. So your new B term, it looks like right here, ax squared plus bx plus c. You're looking for this 5. Okay? So 2 and 7. And anyone, positive or negative 2? Negative. And then positive 7. Because you'll get a negative 2x and a positive 7x, which will add to give you that 5 that you need. Okay? Check this out. How many factors? How many factors do you see? 3 factors. How many answers do you see? Just 2. How many x-intercepts do you see? Just 2. Because 4 does not have a what with it? An x. Because if I set all of these equal to 0, because anything times 0 is 0, I will see that x is equal to 2 and x is equal to negative 7, but I can't put x is equal to anything on this first one. Okay, so it's still a factor, but it's not an x-intercept. Okay, so let's go over here to graph it. So graphing this, I would see my first one exists at 2. The other one exists at 1, 2, 3, 4, 5, 6, 7. Does it look upward or downward? Up. Because it was a positive 4. Okay? You with me? So it's going to look upward like this. So what good is this number right now? Say again? Don't be shy. It's the slope. It's the rise over run magnitude of what I'm looking at. You see what I'm saying? It's like that vertical stretch by a factor of what? By a factor of 4. So way down here where the axis of symmetry is, right? Where it yields my vertex, it will have this kind of up 4 over 1 for that first point field to it. Okay? Alright, guys, what is the x value of that vertex? How do I get it? Add the 2 and divide by 2, right? What's the midway? What's the average? What's the midpoint of that? Negative 5 halves, right? So let's stay as much as we can with fractions only because of what's coming. I'm trying to build your fraction skills. And yes, it is negative 2.5 as well, but if you plug that in, you could get what you would get as far as your y value is concerned over here. Are we good? Let me see. That's it. Are there any questions before we keep going? What's the y-intercept? Negative 56. Because I would put what right here? 0. So right here would be 0, negative 56. We good? Not difficult? Alright, so let's keep going. Let's go to, now we're going to go with bonus points. Alright, so you're in your groups. The first bonus point question that I want you to do, I want you to give me this expression in factor form, okay? So here we go. 2x squared plus 11x plus 12. Because, guys, we're not done. It gets more involved with other case scenarios. Let's go 3 minutes. Alright, first thing we're going to try is GCF something out of all 3 terms. Do you see anything that they have in common other than 1? No. So what we're going to do is now go to the parenthetic piece, And the reason why this is quote unquote more involved is because of that 2. It's easier when that was a 1. And we've been doing them when they're 1s. But now that it's a 2, this is what we're going to do. We are still focusing on these first 2 multiplying to get 2x squared. Notice how I did that. Second step, we're still concentrating on this 12 factors. So let's list those out real quick. Let's try to do it instead of the rainbow, 1, 12, and then so on and so forth. Let's go straight through left to right, but I want you to think in the rainbow as you're doing this. So the first number that I'm going to put is what? 1, 2, 3, 4, 6, and 12. 12, 12, and 12. Okay? Building number sense is what I'm doing. This is why I'm doing it different ways, because I'm not even kidding. This stuff will become very, very easy. What are the first 2 numbers that I want you to try? 3 and 4. Now, I would normally say this could become a 7 or a 1. But I'm not doing that right now. Because this is a 2. The A term is no longer just 1. So you have to strategize. Where can I put this 3 and this 4? Can I put the 3 here and the 4 there? Or could I put the 4 here and the 3 here? You have to make a choice and check. So let's say that I went for the 3 and 4 like this. This is how I check. I have 3. How many do I have there? No. 2 times 4. 8. So I have 3 and 8. These are the numbers that I'm going to ask. Will they be able to get me my B term that I'm looking for? Okay? So yes, they will. I just have to make sure that I place them correctly, which they're placed right now correctly. Because look, if I didn't put the 3 first, exactly how I started today's notes with, order doesn't matter as far as where I put stuff. I'm going to have a 4 and a 6. What could those give me? 10 and 2. But that's not what I want. I want, this one gives me 11 or 5. The one that is the one that I need is right there. Questions? Last but not least, I just need to figure out the signs. What are the signs going? What are they? Both positive. So here are the factors, set equal to 0. This is all I wanted for right now. But if I asked you to keep going and give me the zeros, what would this one equal right here? Negative 4. What would this one equal right here? Some of you don't see it as easily. So set it equal to 0 and solve for x. So negative 3 over 2. Those would be my zeros or x-intercepts. Okay? You're going to have a lot of these, okay, where the A is not 1. The next part we are looking at looks like this. Okay? So first of all, this is in your notes, okay? So this is in group bonus points, this is in your notes. We are looking at factoring something again. Now, if I looked at this, there's no GCF. I can't factor anything, like divide everything out by the same term. So I could look at concentrating on 4x squared. And what are 2 things that I could multiply to get 4x squared? 4x and x. What other 2 things could I multiply to get 4x squared? 2x and 2x. Guess which one we should try first? 2x and 2x. Not the extremes that are further away. 1 and 4 are far away, but 2 and 2 are nice and close by. So I want to use the 2 and 2. just to start. So we have 2x, 2x. What number am I concentrating on now? The negative 3. What numbers multiply to give me a 3? 3 and 1. Notice how I didn't do case scenarios because the 2x's are the same. You with me? It doesn't matter where I put the 1 or 3. Now it's all up to my signs. But before I do that, how many do I have there? 6. How many do I have here? 2. What are the two choices that I could get from this? 4 and 8. And what do I need? A 4. So this one wins. I just need to make sure that I have the correct signs. Okay? Which one's positive? Which one's negative? Positive, wait, what? It's actually the negative here and the positive here. Because look, this will give me a negative 3 times a positive 2x is a negative 6x. You see how I did that? And then this one over here is going to be a positive 2x and a positive 1. And I'm multiplying. And when I add those together, I will get the negative 4x that I need. Okay? Otherwise, it would be 6 minus 2 would be a positive 4. Okay? So these are my factors. Setting each one equal to 0, I would have 2x plus 1 is equal to 0. So 2x is equal to negative 1. X is negative 1/2. This one is 2x minus 3 is equal to 0. Add the 3 to the other side. Divide by 2. Get that. Good? Okay. So, let's keep going. They just get more and more involved. What if you saw this? 4x squared minus 24x plus 36. GCF, yes, GCF what? 4. So everything that's left over is x squared minus, come on guys, 6x plus what? 9. Nice. And from here, I'm going to now break it up into two what? What are these called again? I want you to know the terms. Binomials, right? 2 binomials. So we have 3 factors, but I'm looking at 2 x-intercepts or 2 answers, right? 2 zeros. Why do they call them zeros of a function? Do you know why? Because y is 0. The x-intercept is equal to 0. That's why they call them zeros of the function. Okay? Alright, so here we go. Let's concentrate on which one first? X squared. So I have what here and here? X. Next I'm going to concentrate on what? 9. So I'll have what here and here? I could have 3 and 3, or what else? 1 and 9. What should we start with? The 3. Okay, here we go. So, when I have 3 and 3, what does this give me? 3x and 3x. So, over here, I'm looking at 3 and 3, right? So, it would either give me a 6 or a 0. And I need the 6. You with me? So I could do it here. I know I put them in the equation. I should have put them off to the side. Why on the other one did I not put it off to the side? Because the coefficient of A was not 1. It was 2. And right now, guess what? We can do that because it's 1. Okay? So now I have 3 and 3 will give me a 6 or a 0. Well, we want the 6. So we're good. We just have to put the signs correctly. And what are the signs? Negative and negative. Because look, if I FOIL this out, I still get a positive 9 and a negative 6 for my B term adding. Questions? Okay, so could I do this? These two are the same. Is that the same? Yes, that's the same. So when I have things that I'm going to show you right now, I'm here to show you that if I have a number plus another number and I square it, it's the same as a multiplicity of 2. Multiplicity is just a fancy word of saying it's just a duplicate copy. Okay? It's just a copy. And if I were to FOIL this out, what do I have first? A squared. Here we go. What do I have last? B squared. Positive or negative? Positive. Now the most important part. What do I have in the middle? I have BA math plus AB. Aren't these the same? Can I write this as AB plus AB? Yes, I can. Why? Why can I do this? Multiplication order does not matter. So how many of the abs do I have? 2AB. I want you to, in your notes, very, very clearly put that this is equal to that. Put that somewhere. And asterisk it out. Make sure that you have big notes on that. So, what do you think this will equal? A minus B, quantity squared, we know is the same as 2 of these. What's the first term that I would get? By FOILing. A squared. What's the last term that I would get? B squared. Positive or negative? Positive, because I have a negative times a negative. You see with FOIL, the way I always go to the F and L first. Then I worry about the O and I. And if you haven't realized it by now, the F is right here. The L is right here. And the O and I for FOIL method is right there. Okay? So, negative B times A is negative AB. Another negative AB to give me a negative 2AB. Somewhere in your notes, very big time, asterisk that out. The big thing that I want you to see, guys, and recognize is that you have this middle term. It's the B term. Okay? So, in fact, I should probably highlight that in orange to match up what I'm showing you up here in orange. Right here. Alright, so now that we've seen that, let's look at one more form that you need to learn today, which is this. If I told you to multiply this out and distribute that out, what's the F? A squared. What's the L? Negative B squared. Now look, what's that? AB. Positive or negative? Positive. Positive AB. What is this? Negative AB. Guess what happens to these? They cancel to a form of what? 0. So now they're gone. There's a 0 there that I don't even need that. I could just move that right here. And we call this a difference of squares. Difference because it's subtracting, and squares because each of those can be square rooted. They're perfect squares. Okay? Any questions? Okay. So, let's go to this one right here. There is a method called factoring by grouping. I told you I was going to show you a lot of different methods. So this one right here, we could call the number sense method. If you want to call it the number sense method, go ahead and call it the number sense method. It's like the guess and check method. The factoring by grouping, please put this in your notes, and this will be the last thing that we look at today, okay? Factoring by grouping. The way we look at this, here we go. Some of you might like this. ax squared plus bx plus c. What I'm looking at is first multiplying a times c. Which in this problem would be like multiplying 2 times 12. So 2 times 12 gives me, 24. The second step is factor this a times c. Basically factor this 24 into two numbers that will add to get 11. You see what I'm saying? What are they? 8 and 3. So I've factored 24, which is like 1, 2, 3, 4, 6, 8, 12, 24 with the rainbow. But not only do they have to factor to get 24, they also have to add to get my 11 that I'm needing. So the last step is we're going to rewrite this like the following. We're going to say 2x squared plus 8x plus 3x plus 12. Notice how this is exactly the same as this. And what used to be an 11, I've now created an 11. Okay? The last thing that we will do, because you'll see this on tests and whatnot too, this is why I want to show you this form, even though I think it's inefficient, is we're going to GCF each pair. So look at my fingers. Originally we had 3. We had a trinomial. You see my fingers? So trinomial, we broke this up into 2 numbers so that we have 2 pairs of binomials that we're going to factor out together. So 3 broke up into 4, and then we group and we factor that GCF. Okay? So you tell me, what can come out of the first pair? 2x. Here we go. What's left over inside of this first pair? X plus 4. Nice speed. What can come out of the second one? 3. Right? A positive 3. What's left? X plus 4. And guys, if you do this correctly, your parentheses will match. And that's one of your factors. Look at that. What's in parentheses is one of my answers. And what's outside of parentheses is the other answer. It's called factor by grouping. Questions? So with the factor by grouping, could get away with not doing the factor by grouping, but at the same time, you do want to make sure that you know the method. So for your one more, because we have time, one more question for group bonus points. This one will be big. 64x squared minus 16 plus 1. And what I want you to do is factor this. Alright, resuming the video, here we go. This is the way I would hope that you could do it. Yes, you could do this by factor by grouping. A times C, break it up into 4, and then GCF each pair. But I choose to go for the trial and error. Okay? The first two will multiply to give me this. Guess what I'm thinking? 8x and 8x. Yeah, there's 4 and 16 and other things that you could use, but I'm going right for the middle ones from the rainbow that I showed you with number sense factoring. The last two will multiply to give me 1. What are my choices? Just 1 and 1. You with me? So right now I have 8 and 8, which will either give me a 16 if I add them, or a 0 if I subtract them. Is this 16 what we need? Yep. Now I just have to worry about signs. What signs do you get? Negative. Okay, so yes, this could be written like that as well. So what I want to do is, I want you to give, let's say 25, 25 for each one if you wrote it like this. And if you actually rewrote it like this, I'm going to give 50 points just for that piece right there.